So when I expand this, what was my quick way of expanding this?
Just squaring it.
Right? I take this and I square it, so I get x squared. Then I take this part and I square it, so I get a squared, positive, right? And then I take those two things, multiply them together, and multiply by 2. So basically I get minus 2ax. Okay? You guys remember that? That shortcut? So that was a perfect square expanded, right? What is the vertex of this original quadratic though? What is the vertex?
A 0.
How'd you get that?
A is the x value, is the d value in the vertex, and since there's no value outside, it's just 0.
Right. So remember from the last time we did the whole marble dropping thing, remember the vertex form? It looks something like this. Y is equal to a x minus d quantity squared plus c. Right? So doesn't that look pretty close? The only thing is that we don't have the plus c, but there's nothing to stop us from putting a plus 0 in here, right? Because that doesn't change our equation, right? Adding 0 to something doesn't change it, right? So now we have an equation that's in vertex form. So as Jordan said, therefore the vertex is at b, 0.
A.
Oh, sorry, a, 0. Thank you. A, 0.
A squared.
Pardon?
Never mind.
So if we could get our quadratic, looking like this to this, then we could easily figure out the vertex. Okay, does that make sense? Any questions on that? How do I get the vertex from here? That's what we'll talk about. I'm saying if we can go from here to here, then we can easily identify the vertex, right? So with the vertex, what do we know? What do we know once we find the vertex of a quadratic? I know I was thinking back to like 2 units ago now.
Everything.
Well, think about that marble dropping, right? We knew the vertex. What? Good job, Ryan. Right? We know the minimum or maximum of that equation, right? So just like the marble falling, we knew that was the highest the marble was going to be. That is our maximum point. Okay? It would be likewise if the the parabola is opening upwards, we know the minimum point. So, an extension to this, well, if I have an equation like this, y is equal to x squared plus 18x plus k, what value of k will make this a perfect square? Would this actually be a perfect square? 9, 81. How are you getting 9? How are you getting 81?
Because if you do 81 as k, then you would have to get a number that adds up to 18 too, and 9 times 9, or 9 and 9 add to 18.
Yes.
So 9 and 9 add to 18, and then we took that and we square it, right? So another thing that we do, if we noticed over here, was that this is 2 times something, right?
Oh.
Right, so if we notice over here, this was 2 times that middle term, right? So if we go back over here, well, basically here we have 18 is equal to 2 times a. Actually, I don't like that variable a, but I'll use it for now. I have to change my foils. Because we know a means something else in our quadratic equation. What does a mean? What does a mean in our quadratic?
Slope? I don't know.
No, that's slope. Good, stretch and compress, and also what else? What else do we know about a?
Upwards.
Yeah, upwards or downwards, right? So if it's positive, it opens upwards. If it's negative, it opens downwards, right? So for now, we leave it as a. So therefore, we know that a is equal to 9. So we just take a squared is equal to 81. Therefore, y is equal to x squared plus 18x plus 81, that's a perfect square, trinomial. Okay, so that's how we could get for k. Right? Any questions on that? Right? So if I gave you a question like this, and you factored it, so if we factor this, we would normally go, well, we get y is equal to, we would do our whole PSI thing, and eventually we would figure, well, it's x plus 9 quantity squared, and therefore so we say, well, the vertex here is, this implies that the vertex is at negative 9, 0, right? So it's nice and easy when it's a perfect square. We could easily factor that. We went through the tools. Okay? So now, the question is a little bit different now. Y is equal to x squared plus 18x plus 75. Is that a perfect square trinomial?
No.
You know right away it isn't, because what's not a perfect square?
75.
Yeah, 75 is not a perfect square. Okay? So the question, so what we can do is, we can sort of rewrite this equation and say, well, we can't change anything, these things really, right? Plus 75 over here, right? So I sort of broken up a little bit, put some space there because I want to put some stuff in there now. So now the question is, what would make y is equal to x squared plus 18x plus k a perfect square? Right? What makes that a perfect square? Plus 6.
Plus 6.
Yes, sir.
Plus 6.
What?
81.
What do you mean?
I mean, 81 is
Plus 18.
What value of k would make this a perfect square trinomial?
81 would.
But if you
And
plus
he had
6,
6.
7.
Okay, no, yeah.
Six,
So
yeah.
the point is 81, right?
Yes.
Positive 81. So what we want to do is, we know if we have positive 81, that makes it a perfect square. Well, we're going to put in here plus 81. Am I allowed to do that?
Oh, not a problem.
I say yes, no.
You have to do it to the other side too.
Yeah.
I have to do it to the other side? Okay. I could do it to the other side. Right? So that's good. That's what we learned from solving equations. Right? Do one to the other side. So I don't want y plus 81 on the other side. I could. It'll make my job a little bit longer in the end. You could do it this way. What else can I do? Instead of adding 81 to this side, what else can I do? To keep this equation true. Remember, all mathematics about keeping stuff true.
Add
Elizabeth?
11.
I'm not adding. Why would you add 11 and make that?
Don't you put like, if you go get the closest square root and then you add whatever is left over, or that's something else?
That's something else.
Oh.
Right? We added. It's okay. Nice try. We added 81 here. We just can't add 81 to something. What can we add to something that's not changing? 0, right? We did that before with the quarter. So it's not 0, but what can we do to make that 0 really?
This minus.
What can we do to make that 0 really?
Minus 81.
Minus 81.
What?
Thank
I
you.
was saying that at the
81.
beginning, but I didn't think it was right. Just
What?
I mean, it looks stupid. Like, why would we add 81 subtract 81? Like, that's the most stupidest thing you can do. And you know what? Way back before somebody did this, and there's a math teacher would have said this, so yeah, why would you do that? You're a stupid idiot. Right? But that's what math is about. It's about doing simple things to find out new discoveries. Because what happens with this is, what happens if I change my brackets a little bit now? Change my grouping a little bit.
Minus 81 plus 75.
Minus 81 plus 75.
Why can't you just Do
Whoa.
plus 6 minus 6.
I just want to work it out so everybody sees what we're doing, right? Because if I do the jump to plus 6, nobody sees what you do. What magic did you do? They think it's magic.
No,
No, we have a smart class.
Why? Yeah, but the thing is, you need to pull that 81 out. You need to see this
But we
81.
understand that the 81's there, so you don't really have to see.
If you can see it, but not everybody sees it right away,
Making babies.
right?
Finally making sense.
So we know that we factor this, right? What do we get?
We get x plus 9.
Quantity squared, right?
X minus 6.
And what's minus 81 plus 75?
Minus 6.
Minus 6,
Nice.
Magic.
Wow.
right?
Could you see the middle school?
You can skip the middle stuff. What I was, you know what? I can't even skip that middle stuff to be honest, because I need to see this first, so I could do this math properly, right? If I didn't do this, I'd probably come up with like minus 4, right? It doesn't hurt to take those steps because I need to visually see it. I got short-term memory, right? I remember negative 6 like for half a second, and later I was like, what was that number again? Nothing wrong with writing it out. Okay? So now what's my vertex?
Why would you add the negative 6?
Sorry?
Why would you, like, I understand to make it even, but.
Well, I'm not adding, the negative 6 comes from the result of simplifying this, right? So when I simplify this, I just get negative 6.
But wouldn't you just have, why would you have to add those two together?
Well, I don't, but
Like the 81 and the 75, how come, like, I don't know how to explain it, but like, the negative 6,
well, it's negative 81 plus 75. What is that?
I get that, but,
It's just what's left over.
Negative 6 is the.
so when you're solving, like, when you're solving it, you have to,
I'm not solving it,
but like when you're doing the thing,
right?
you wanna find the perfect square first and then,
Well, because, yeah, so I thought the perfect square was x squared plus 18x, and this had to be plus 81 to make this part a perfect square, right? So this is the part that gave me the perfect square trinomial. But because I'm adding 81 to make it, I have to subtract 81 at the same time. So now I'm combining negative 81 plus 75, that gives me
negative 6.
negative 6, right? And this part, now I could just factor, and I got x plus 9 quantity squared, right? So therefore my vertex is what?
Negative 9, negative 6.
Is, sorry?
Negative 9.
Negative 9, negative 6.
How would you get the 9 again?
How do I get the 9 again? Right here?
Yeah.
Well, basically I'm factoring this, right? So remember we went over here when I was factoring this. So you could do your whole PSI, right, product sub integer, or recognize the fact that this is a perfect square, right? This is a perfect square, this is a perfect square, right? The x squared is a perfect square, 81 is a perfect square, right? So I just take the square root of x squared, and I get x. Square root of 81 is 9. I have a positive, and then I get the square, right? And just double check, 9 times x times 2 is 18x, which is my middle term. So that's why we had the whole unit of factoring, right? It's all practice and practice just to get us to this point. Okay, so does that make sense? Right? So we just went from a form that was standard form, right? That's what we call standard form. Can't tell anything from that, to a vertex form. Okay? So very similar question. What is the vertex of this fallen quadratic equation? How might we approach this?
We shan't.
We shan't? Shan't a word? I have to ask Mrs. Churchill.
It shall not.
We shan't.
Yeah.
Thank
It's
you.
a word.
Okay, I'm a math teacher, not an English teacher.
English is fine.
Although apparently I know what New World Order is, and you guys can't. Okay, so how will we go about doing this? Well, is 2x squared a perfect square? 2x squared is a perfect square? Well, what's 1 squared? Square root of 2 is not 1. That's fine. A lot of people are going to make that mistake, right? So it's kind of tricky in that sense. Square root of 2 is not a perfect square, right? So what we want to do is we want to try to get that first term to be a perfect square. Well, what number can we change that to be a perfect square? What did we use the first time? What did we use over here? What was the coefficient of the x squared there? 1, right? So what we'll try to do is we'll try to do a partial factor here. So we get y is equal to 2 x squared plus 6x minus 7.
No way.
Right? So I just did a partial factor, right? We only took the first two terms, factor, but left the negative 7 alone. Because I can't factor a negative 2 out of that. I could try, but it's going to make this a little bit more complicated.
Don't you do it to everyone?
No, that's what I mean by a partial factor.
So
Okay.
much.
So I only took these two terms and pulled out a common factor of 2. Okay? I don't want to pull out the GCF. I don't want to pull out 2x, right? Because I still want a quadratic equation in here that I could try to make it a perfect square. So the question again is, what value of k will make x squared plus 6x plus k a perfect square? Perfect square trinomial. Well, we use our formula, right? We take 6x, take that divided by 2x, but just really take that by divided by 2. 6 divided by 2 is equal to 3, and we take that and we square it, and we get 9. Right? Remember that same formula we had? We just took that middle term, divided by 2, and then we just square it. That's what we did way back over here. Right? We took the middle term, because 1 is the coefficient, take half of that, and because that only gave us that a, we need to square it to make that perfect square. So now I have to rewrite this equation as y is equal to 2x squared plus 6x minus 7. So what am I filling in that space is there? I left a whole whack of space here. Michael?
Plus 9. And then on the outside minus 9.
And on the outside minus 9?
Yeah.
Does the minus 9 go on the outside or the inside? That's a good question.
No, inside.
She did last time.
Because if you put it outside.
If I treated this thing separately, I added the plus 9 inside the brackets, it's gotta stay inside the brackets. Okay? Here, I didn't really have any brackets to work with. Right? So the a plus 81 minus 81, I didn't have any brackets to work with. So this in itself was on its own. Right?
But the one with the second
I was using the brackets for grouping, not for multiplying. Right, just so that you can see that basic here is really adding 0. Right here is really adding 0. And then I just chose to regroup it, so I got my perfect square, and I left these numbers that I just want to simplify. So good question. Everybody understand that, the difference? So we use the brackets. So here I need to do the minus 9 inside as well. Okay? So now I have a perfect square inside, except this is going to mess us up a little bit, right? So what I want to do is I want to distribute the 2. So I sort of want to group it like this, because that's my perfect square trinomial, and then I have this left over. So what I'm going to have is y is equal to 2 times x squared plus 6x plus 9, right? And then minus 2 times 9 minus 7. So now you can see why the 9 had to be inside the brackets. Because this is really having an effect, the 2 needs to be multiplied as well. So basically what I did was I distributed the 2 to that trinomial and 2 to the negative 9. So now I'm left with 2, y is equal to 2. Well, what's that going to factor to? What's this trinomial going to factor to?
X plus 3.
Yeah, we know it's a perfect square trinomial, x plus 3 quantity squared. Negative 2 times 9 is negative 18 minus 7. And we'll simplify that even further. And we get minus 25. Right? So now what is our vertex? Vertex is, sorry, Ryan?
Negative 3,
Negative 25. So this one is a little bit different because this one has a stretch factor of what? It has a stretch factor of 2. Okay, so you see how we've sort of come full circle? From Unit 4 when I taught you this form, right? And you're trying to understand this form, and we got so much information from this vertex form. But many times in life, we don't get it in this form. We get it in something like this. Once we can convert from this to this, boom, it's Unit 4 review all over again. You tell me what the axis of symmetry is, right? Tell me if it goes as a maximum or a minimum. All those things that we talked about, you can discover now. Okay, so any questions in this example?
I have one question.
Yeah.
Up in step 2, when it's that
Right here.
When it 2, it only multiplies over to the x and to negative 9. Why didn't you change the?
Well, really, I could have multiplied 2 by everything in here. So I could have 2x squared plus 12x plus 18 minus 18. And then what I had to do was factor 2 back out just to get that. And then so that I could get my perfect square trinomial. So what I did was I just took 2 and I just multiplied by this trinomial. Right? I just multiplied by that trinomial, so I'm left with 2 times that. And then minus 2 times what was left over. So I need to distribute this 2 into everything in that bracket. So if we would have left the negative 9 out, like what the original suggestion was, our vertex would have been off by 9. We would have had the minus 16 point. Okay? Questions? So this is what we call completing the square. Right? You find that value of k, so you can make something a perfect square trinomial, so that we can hopefully find the vertex. Okay, so one last question. You could try this one on your own.